Hello, everybody.
Hello.
Hi.
Hey,
Greetings
Armen,
from
welcome.
Seattle.
Good evening. What time is it with you?
It is 12:30 at night.
Oh my God. So
So
actually,
you guys are at the end of a long day for me, but it's a good end.
well, thank you for that, Armen. We agreed that I would ask you a few questions to get things started. There is already something about you and J Street Technology on the event website, but can you tell us a little bit about yourself? I saw something about liking certain vehicles, and can you tell us a little bit about your company, J Street Technology, please?
Sure. Yeah, I can actually. I'll just advance to the first slide here and tell you a little bit about me. So yeah, I've been running J Street Technology for 24 years now, and we build database applications of all types, both for the web and in Access. So my area of expertise is definitely Access, although I do have web developers on my team as well. Can everyone in the back hear me okay? Is the audio good? Yes, thank you. Okay. So yeah, I speak at conferences around the world. I did speak at the Vienna conference last year, but not the first one. And I've spoken in London a few times, and in Australia several years ago. And I've really enjoyed doing that. And I enjoy running my business. I love learning about all different types of businesses and building applications to suit them.
Okay. And I have actually separated this into two different parts. What are some recent things that you've been doing within your company that are not Access related, that are interesting to share with the audience here?
That are not Access related? Well, right now we're in the middle of building an application that helps a shipping company up in Alaska keep track of the service that they do for fishing vessels that come in to their port. It's up in Dutch Harbor, Alaska. And I have not been there myself. In fact, none of us have been there, but we're building all the web technology for them to be able to keep track of all their operations. So that's interesting. And there's no Access involved in that one at all, although we always use SQL Server as a backend database. So that part of it is familiar, I'm sure, to everybody in the room.
And what is the front end you're using?
We are using ASP.NET MVC. We've just switched to MVC Core. So we were using just regular MVC, and now we're switching over to Core, which is quite new, and we're actually helping Microsoft debug that for them. So I'm trying to figure that out.
That's nice. I can actually tie that in with the last question, so I'm swapping two questions. You must be close to Microsoft if you're helping them debug it. What does it mean in the sense of, well, obviously it's fun, but what are the advantages and the kudos of being an MVP?
I really like being an MVP. I never really expected to be one. I knew that there were MVPs out there, but somebody noticed that I was doing a lot of helping with user groups and speaking at events like this. And so I got nominated, and I've been an MVP for about 13 years now. I really like the connection with the product team. I've gotten to know McCall over the years. Hi, McCall. I can see you sort of. Yeah, I see your hand. And I really enjoy communicating with my fellow MVPs around the world. We have an email list that we use to keep in touch with each other. And then every year, Microsoft sponsors what they call the Summit, which is an MVP event where they invite everybody to come to Redmond, Washington, which for me is not a very long journey. It takes me about 20 minutes to get there, just across town. So it's local for me, but people come from all over the world, and we get to talk about everything with Access, and we get to work with McCall and her team to help shape the direction that Access is going and to learn more about the product. So I really appreciate doing that.
It's interesting because I was just actually emphasizing in my introduction to the people here not really the community aspect, but actually the networking aspect of getting together. And it mirrors what you describe, why it's nice to be an MPP. So I think that's another point of why we should actually mingle a little bit here. And my last question before you actually start on your presentation, what are some things that you have been working on with or in Access recently?
Well, we just, it was interesting. McCall and one of the developers on the Access team and I went and visited a customer in Minnesota, right out in the middle of our country. We flew out there and visited with them, and they have a business where they order a lot of fresh fruit, like apples and oranges and things like that, and they repack it into gift boxes. And high schools and other community organizations sell those gift boxes as fundraisers. So they make money that way. And this company was very unique. It's not a normal ERP system. So we had to build everything from scratch. And we built that system with an Access front end and a SQL Server back end. And it was pretty significant. It was a few thousand hours of development. And they were really pleased with it. They're still using it. And so we were able to go out and do a customer visit. And it was really fun to go out. And by the way, we built that whole system without us ever meeting the customer in person. We did everything by phone and web conferencing. In fact, we didn't even do video conferencing. We just didn't bother. We knew each other's voices and we did the whole project. So when McCall and Shane and I went out to meet them, that was the first time we'd ever seen them.
Wow. And I hear it's about your first time to do a video conference as well, isn't it?
Yeah, I've done screen sharing and voice, but I've never done a video conference like this. So it's an experiment for me, and it's so far I really like being able to see everybody.
You're looking good.
Oh, I look good for being up this late.
Go ahead with your presentation, Armen, if you would.
Thank you very much. Okay, well, again, like I said before, greetings from Seattle. I'm really happy to be here this way. I'll just continue going. Now, I know that it might be easier to leave all the questions till the end, but I do like, if there's questions that come up during my presentation, then I would like you to go ahead and raise your hand. And if I can't hear you, maybe you can stand up and ask your question. So I'll try to watch for hands, and maybe Daniel can help me with that. But I'll just go ahead and move forward. But I really like this to be as interactive as possible. So let's see how that works. So I guess the way I would start this presentation about database design is, why do we care so much about database design? So I wanted to kind of let you know my thoughts about that, and we can kind of go through it and see how that works. And if at any point you can't hear me or you need me to adjust my volume, just let me know, okay? I think of databases as the foundation. It's the foundation underneath a house. The house is your application. You can do a lot of fancy programming to overcome a bad database design, but there's no reason to do that, because a great database helps you out in a lot of ways. First of all, a good database design is much easier to query. I think we've all had to struggle with queries to get the data that our customers need. And it can be very difficult if the database is not designed well, but it's so easy when it's designed well. So it pays you back that way. The other thing I find about good database design is that it's future resistant, meaning that it's not future proof. You might need to change it sometimes, but it's future resistant in the sense that you can expand and extend the database in ways that you might not have known that you would need to do at first, but a good database design is easier to expand. I think it impresses your customer. I have a typo there. It impresses to your customer. That's not correct English. It impresses your customer and sets you apart from your competition. And a lot of people question me on that, because they think, well, wait a minute, my customer doesn't really look at the database design. But because of these other benefits, and if you really teach them what a good database design looks like, I think it does set you apart. And so I'll say a little bit later in my presentation that we actually deliver the diagrams, the database diagrams, to our customers, even though they might not understand it fully. We find that it's a good thing to deliver. And the last thing is, I look at databases from all over and I see really bad ones. In fact, that's the reason I keep giving this presentation, is because there's a lot of bad databases out there. And I think that if I see a bad database, I think that an amateur built it. And maybe that's true, or maybe it's a professional, I don't know, but it just doesn't look good. And so I have to then decide how to tell the customer that this database that they had built for them is not great, and I don't know how we're going to fix it other than just starting over. I actually wrote an article that you're welcome to look at on our J Street Technology webpage. It's called 9 Signs That an Amateur Built Your Access Application. And 1/3 of them are about the database design. So I think it's really important, and 3 out of those 9 signs are all about database design. Okay, that's why I think it's important. Let's dive into some basic principles that we use at our shop for database design. Now, I will tell you right now that I absolutely am sure that many of these are going to be familiar to you, and some may be new, but that's why I like to sort of put it all into one place and have a conversation about everything from top to bottom. So let's get into these. First of all, I do this presentation for college students sometimes, and they all learn about normal forms. So raise your hand if you are familiar with the normal forms of database design, like first normal form, second, third. We've all heard that, right? After I went through school and graduated from university, I completely forgot about all the normal forms. I didn't need them anymore. I didn't care anymore, because the principles of good database design don't need to be named, and I can't remember what the difference between third and fifth normal form is anymore. It doesn't matter to me. I go by just basic principles, and these are the ones that we follow in our shop, and they're really straightforward. I tell database people a good designer only knows 3 numbers: 0, 1, and many. So if you have anything in your database where you've numbered it, you have month 1, month 2, or phone number 1 or phone number 2, or email 1 or email 2, those types of things, I always think you're starting to go down the path of bad database design. It doesn't mean there aren't exceptions. Sometimes there's a reason to have it something numbered. But most of the time when I see numbers in a database design, I know that they've gone off the track somehow. Another principle that's really straightforward, but people get it wrong all the time, is all the fields in a table should go together about a single subject. If you try to mix people, let's say customers and orders, you try to mix them together and there's something about those 2 subjects in the same table, then I think you're violating a good database design. And that's just a really basic thing, but I see it done incorrectly all the time. So that's why we're sort of having this basic conversation about it. And then repeating groups, again, with the numbers. 0, 1, and many are the only numbers you should have. So if you have anything in your database where there's a group of something and it's repeated in a table, fields that are repeated, you're probably going off on bad design. So we have to watch for that. And then the last thing I'll say about this part is no temporal fields or tables. How many people have seen a table saying something like sales 2017, or history of a certain year, or even a query that says January, January performance numbers, something like that. Anytime there's a structural item in the database that has years or months or anything like that in it, I think there's a design problem, because my bullet point underneath down here, and I think, can you see where I point my mouse when I move it? I'll move my mouse around to point at things. I say the business should be able to run indefinitely without any structural changes. So think about that. When you're running a business, you should be able to go year after year without creating any queries or any tables or any fields. Your database should be structured in a way that you would never have to change that database structure just because time is passing. That makes no sense to me. but I see that all the time where people have to archive data and they archive it in maybe a table that has a year on it, and they're just doomed to always repeating that process. So anybody have any questions about these principles so far?
Yes, Armen,
Right.
can you elaborate on the 0, 1, and many?
Say that again?
He's asking if you can elaborate on the 0, 1, and many.
Yes. So what I'm talking about there is if you need 3 of something, then it should be in a child table. It should not be columns, it should be rows. So every row will only contain 1 item. You might have 3 or 7 or 10 items in that child table, but if I try to put 3 items in the table as columns, then I'm violating good principles. So I should never have to number anything or have a group of values in a table. The many becomes single items in the child table. Does that help answer the question?
I understand. Thank you.
Okay, great. All right.
I've got another question
Yes, please.
about this temporary tables. What about a reporting process if to collect data from several tables into temporary tables in the next steps to reuse the same table, but for another query?
Right.
I said a query.
I'll jump in here a little bit, Armen. I think there's a little language confusion maybe.
Yes.
That you're talking about temporary as something that goes away, and he's talking, if I understand correctly, about something that has time associated with it.
Yeah, temporal is just a meaning of time or date specific. But that's a good question because I will talk about temporary tables, not temporal tables. I know it's a similar word. And then another piece here that I always say is each field should only contain 1 piece of information. An example, the best example I can think of with that everybody here knows about is a name field should be a first name, a middle name, and a last name as different fields. If you put everybody's name together as a full name, then you're actually putting different pieces of information into the same field. And what I always tell people is database, it's very easy to glue things together in a query. In other words, you can make a full name by concatenating first name and then last name. It's easy to put things together in a database. It's very difficult to rip them apart. So what I always say is store the information in its most basic form. And this goes for lots of things, but the name is the easiest one that people relate to. But even order numbers and other things where you may have an order number that's for humans to read, and it says maybe it starts with the location. You know, there's an Amsterdam location and another location. So you might say, well, the order number would start with AM or something for Amsterdam. Well, I would say don't glue that together in the same field. Have the prefix and the number separate. So you always want to be able to glue things together easily, but ripping them apart is hard. So that's why I say to do that. Now, there are exceptions to this rule. The classic one that we use is an address field. I don't know how your addresses work in the Netherlands, but in the United States, you might have a number and then a street, right? Like 123 Main Street. Those are technically 2 different pieces of information, but we hardly ever have to show them separately. They always go together. So that's why we can put them in an address line 1, and that works out okay. So there are exceptions. We never should go to an extreme on these types of things. We just want to make sure that it's making sense to us. My favorite book about database design for very practical database design, because it's not really a textbook, it's more of a working book that has lots of great examples, is this one here, Database Design for Mere Mortals, and it's by Michael Hernandez. I think this is probably the best practical database design book, and he doesn't really go into normal forms or anything really technical. It's very practical. Okay, we'll move on, and just go ahead and raise your hand or shout out, and Daniel help me if you have a question. Okay, let's talk about naming tables. How many people in the room, raise your hand if you have a standard for naming tables, like you always do it the same way? Yeah, okay, good. This is our standard. And I would always say with standards is, I don't care if you use mine or yours, just use one. Like make sure that you're consistent when you're using it. Because if I look at your database later and I see that you have some named some one way and others named another way, it just looks like, it looks messy to me. So here's a standard that we use, and this is pretty common out there, and we've extended it. We have extended it for our own uses, and I'll show you what we've done. So everyone's familiar with probably with the concept of a prefix, and so we do prefix our table names. Some people don't do that. We found that it's very helpful over time to understand the database and how we're using it. So here's our prefixes. TBL for main tables. This is like customer or order or whatever the main information is in the database. When it's a lookup table, really the only reason that table exists is to populate a drop-down list so you can choose a value. TLKP for lookup. And then when people sort of agonize and say, oh, I don't know, Armen, is it a lookup table or not? It's kind of important. I say, look, if you're in doubt about it, just make it a TBL instead. Lookup tables should be very simple. If they have more than about 5 or 10 fields in them, it's probably a TBL. It's probably a main table, not just a simple lookup. Now then we have cross-reference tables, which is obviously how you build a many-to-many relationship. We call them TXRF for cross-reference. Alphabetically, they sort down toward the bottom, so we can kind of keep all of our cross-references together. Some people call them join tables or other names. We just call them cross-references. I don't care. I've seen the word join a lot. It's fine. Whichever way you want, just keep it consistent. Now I say equal value. What do I mean by that? What I mean is that a cross-reference table really should be defined only when two keys need to be joined together from other tables, but they're both equally important. In other words, you cannot have one of them be null and still have that record make any sense. I'll give you a quick example of a cross-reference that you'll understand because it's really easy to get. When you're a student in a classroom, you're a student that's enrolled in a course, let's say. That enrollment record would not make any sense if the student key was null or if the course key was null. So they're of equal value. That's why it's a cross-reference. It's joining two keys together. It could be two or more. We've had cross-reference tables that have more than one key, but they have to have at least two. Otherwise, if it doesn't feel right, in other words, if one of them just seems like it's a lookup value and it's not that important, and maybe it could even be null, then just it's back to a TBL. It's only a cross-reference if you have to have both keys and they're both important. Now, this is something that we came up with many years ago, and we have loved this. So I will really recommend this naming convention to you. We have a prefix called TVal. It stands for values list. And you remember, Access has a values list in the form, and you can drop down a list of static values and you program them right into the form. Everyone familiar with that? Yeah. It's actually a terrible technique. Please don't do that. You don't want to put values list in a form because it's not self-documenting. If you look at the form, you don't know what the proper values need to be unless you look at the code. And if you ever need to add a new value, then you've got to go into a form and do development and code. That's a terrible way to do it. What you want to have is in a table. Now, you might have some things that you say are completely static. One example would be like order status. Maybe you're placing orders in your system and it starts off as like a quote, and then it's a confirmed order, and then you ship it, you ship the product out, and then you close the order. Those are statuses, and you have to do programming based on those statuses, and so you're not going to add or remove those values. They're static. So that's what I mean by static, right? Those values never change. Well, you could put them in a TLOOKUP, but then you would be tempted to have a user interface where users could add or remove values. And so we name them TVal instead, meaning if one of my developers sees a TVal table, they know that no human is going to add or remove values from that table. There's no user interface that allows you to add or remove them. And then they know that they're safe to program against them. So for example, if they need to add up sales, maybe they're only adding up confirmed and shipped orders, right? For sales reporting. Well, they can hard code the order status of confirmed and shipped, and they can ignore quotes and canceled orders, let's say. So it allows them to be confident that they can use those values without worrying that someone has added or removed them. Does that make sense to everybody?
Yes.
Just nod your heads really big so I can see you. Yeah. Okay. So that's what I mean by a T-val, and we use those all the time, and we make sure that we understand that there's a good reason to use a T-val. There's a reason that we're going to code against those values. And then we have other tables that I'll go through quickly. We have system tables. Really, these are like single configuration values that you need just one value in the whole system. So we just store it away in a system table. And then someone mentioned the temporary tables. We prefix those with T-work, T-W-R-K for work tables. And we often will put them in a separate access database so that we can compact and repair that database separately when our main application opens. If you put work tables obviously in the front end of an access application, then your access database can expand, or what we call bloat. You know, it can get bigger and bigger because access never recovers that space until you compact and repair. So it's nice and clean to put that in a separate database. So that's what we do for those. And by the way, if you're all welcome to download, if you like, our we have an access relinker. So I think it's one of the better relinkers out there, and it's free. You can just download it and use it. It's on our website under the resources page. We have a downloads page. And what it's nice about it is it'll relink to access databases silently and without prompting the user if they're in the same folder. You can turn an option on to do that. So that's really nice for work tables, because as long as that database is in the same folder as the application, it'll relink silently without any prompting. Okay, and there's a bit of a debate on this, and I think I'm right, but you know, I always think I'm right. The singular form is better for tables. A lot of people name tables, they say Armen, but there's lots of people in the people table, so of course it's going to be plural. You know, it's going to be multiple people, and I just think it's awkward. You notice that it's not even the same names. You know, in the English, person and people, the plural form is a completely different word. You must have words like that in Dutch as well. So it's like, it's just irritating to have like a field called people dot first name. It doesn't make any sense. And it's always a longer word. Anyway, there's lots of reasons I don't like plural table names. So our standard is always use these prefixes and then always make it the singular. Okay, before I go on, any questions about table naming before I move on?
Yes, Armen. Sometimes a single record can be something plural. Do you have a convention for that?
A single record can be what?
Something plural, something more of one item.
Every table can have multiple records. So I understand that every table can have lots of different information in them, but I would argue that a single record in a table is always about one of those items. So for example, person or order, location, you know, these are tables that have multiple records in them, but each one is about one. Each record is about one of those. If you have multiple items in one record, then I think you're violating the 0, 1, or many rule. You should not have many items in one record. I think that's a database design problem.
No. We have sometimes single entities that reference to a plural item. So we distinguish between, we don't by definition have always single words. Sometimes you have a single entity that's referencing to a plural item.
I guess I would need to hear an example of that if you have one really quickly.
Yeah, well, let me think a while. We had one just a couple of weeks ago, but not so important.
Okay, yeah, I would be curious. You know, we've built hundreds of databases, and I can't think of an example where there was that you had to keep track of multiple items in one record of one entity. So that I would be curious about an example. And I'll have my email address at the end. So if you think about it, you could always email me and say, oh, Armen, I came up with an example. And I would love to have that discussion with you.
Well, if you have, for instance, 4 or 5 groups in one list, and each group is a set of persons, then the group name is plural.
Yes, but it would still be one group. So there would be, I would still call that table group, not groups.
But sometimes you refer to the group as in plural. That's the case.
I see. Yeah, I see what you're saying. Our standard is to always use the singular form, even if you're going to refer it to multiple groups sometimes. So, okay. Let's go on to table structure. Let's see here. I'm moving my screen around. Okay. So first of all, I have a religious question for you guys. This is the only time I'm going to talk about religion. I'm in the meaningless single surrogate key religion. What that means is we don't use natural keys. So I would never use someone's national ID card. I don't know what you have in the Netherlands. We have a social security number. We would never use a meaningful number or value as a key. We always use auto number, or in SQL Server, it's identity. So there are people out there, there may be some in the room with you. You don't have to raise your hand. I don't want to shame you, but, there are people that really insist that they really want to find natural keys, like some key that has some meaning for that item. They want to find the natural key for a table. And I just think that that's not a great way to go. For one thing, natural keys can change. They can be wrong. You know, you might need to change them because they were entered incorrectly. And I just don't agree with keys changing. The other problem with natural keys is that when you have children of them, you have to combine the keys together to make them unique. So has everybody built tables that have multiple primary keys? You know, where you have the key symbol next to 2 different fields? I don't think that's very good, because then if you have a grandchild record, another one underneath that, now it has to have 3 keys to keep it unique. We get away from all of that by just making every table have a single, meaningless, automatic numbering key. So does everybody agree with me, or do we want to have a little talk about it?
Well, I think there's one exception.
Okay.
Table.
Say it one more time.
I think there's one exception on that. That is the cross-reference table.
The cross-reference. I'm glad you asked that question, because it's going to be coming up in just a second. So let me get to it, and then we'll cover that. What I do is I do recommend that we include a create timestamp in every table. This is something you get free of charge with SQL Server or Access. We just default the time and date into the create timestamp field. So now I was 1 bullet point off, but here's your question. For many-to-many tables, for the cross-reference tables, we store the keys from the related tables. That's obvious, right? We have to store, let's say, the 2 foreign keys. Like in my example earlier, we have a student, we have a course. The cross-reference table is, let's say, enrollment. This is the student that's taking that course. And then any related data that might go along with that. But you notice I say each table still gets its own single primary key. And you might say, but Armen, you just said that those 2 fields are they're both important, And so they could form the primary key, those two foreign keys. Is that your question?
Yes, it's clear now.
Yes. Here's why we do not do that. The reason is that it may be possible in a many-to-many relationship to have duplicates. It's possible that you could say that these two foreign key values could repeat multiple times. Maybe they happen on different dates, maybe they happen for different reasons or different statuses, but it's possible. In that case, you're not going to get away with having them be the primary key, because you can't have duplicates in a primary key. But the better reason, even better reason, is that table might have children. If there's a child table underneath that, then if you've joined two keys together to make a primary key, then the child table now has to know who its mommy is. And mommy has two names now. So now the child table is going to have two keys for its parent key, and then it has to have its own unique value. And you can see how it could propagate downward. And even if you don't think it has a child table now, it might someday. So we say, let's just keep it straight the entire time and let every table have a single identity or auto number key, even if there's another one below, beyond that. Does that make sense?
Yes.
I hope so. And then you can always enforce uniqueness. If those two, like a student and a class, are a unique combination, you can always add a constraint to enforce uniqueness on those two keys without making it a primary key. It's just all it is a constraint. And then I will just say really quickly, and I have to speed up here a little bit because I've got to try to keep this within time. In SQL Server, I do recommend you always put in a row version field. It's also known as timestamp, but that's a bad name for it. It really should be called row version. We just call it RV and we stick it in the table. And basically that allows concurrency errors to not creep in with Access applications. And I can't get into detail now because of time, but I do have a slide deck called Best of Both Worlds on our website in the downloads page, and you could read all about it. Okay, let's go through naming fields quickly because I want to get to a couple of examples that might be helpful for your projects. Naming fields. We don't use prefixes for fields. We only use them for tables. In other words, we don't say that a field is a string or a number or something like that. We just name the field what it is. However, we do prefix field names with the table name. So for example, if you had a person table and the first name, we would say person first name is the name of the field. Now, some people say, Armen, that is too long. I don't want to type that much. And I say, too bad. The reason I say that is because you're only typing the field name a few times when you're developing it, and Access has IntelliSense anyway, and it's not that hard to type field names. But guess what? You're going to read and have to understand the field name for the rest of your life. So I would say it's better to type a little bit longer now and then have it be very clear for the rest of the life of the database. The other reason that I really like it is you'll never get a reserve word accidentally, like date or value or something like that, if you prefix it with the table name. There's no such thing as a reserved word that has two words together. So the moment you put, something date or, table name date, you don't have a reserved word anymore. So you're good. You don't have to worry about it. And it also self-identifies that field throughout the entire database. It's unique. So whenever you encounter that field in a report or a query or anywhere, you know that it's not a customer first name or something else first name. It's a person first name. You know which table it came from. So we do this throughout all our databases. The next thing I'll say is there's an exception. If you have a foreign key in a table, then you just name it exactly the same name as the primary key that it came from. And I'll tell you why. If I have person first name, person last name, person this, person that, lots of person, 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 and then I see a foreign key like some kind of status or something like that, or their favorite color. You know, I might see color key. It doesn't have person on the front. So it stands out to me as a foreign key because it looks different. So that's why we name them that way. And you always, without any confusion at all, you know where that key came from. You know where the primary key is because it's the name that foreign key is. Now there's exceptions. Sometimes you need to qualify a foreign key, and I'll get to that in a minute. But for now, let's just say that a foreign key is named the same as the primary key. Like if you're in an order, if you have order status, it would be order status key. That would be it. It's exactly the same name. We capitalize each word with Pascal case, meaning that the first letter of each word is capitalized. No spaces or special characters except underscore, which I'll get to in a minute. We do suffix fields. So we put something on the end of a field to make it more clear sometimes. And then the last thing I'll say is please think very carefully about naming. When you name fields, they have so much inertia, you cannot change them later very easily. So this is why we sometimes just argue for maybe an hour, not an hour, we argue for minutes about the proper name of a field because it's going to last so long and it's going to be difficult to change. Okay, I talked about suffixes a minute ago. Everyone understand what I mean by suffix? It's something you add on to the end of the field, not the beginning. So we use suffixes for special scenarios, and I'll go through them quickly because I got to move quickly here. When you need to, though, how does this translate to Dutch? I don't know. Disambiguate. When you need to take two foreign keys and know which one you're talking about. For example, if you have an order, you might have a customer key to ship to, but another customer key that is going to pay for it, like the bill to. So you can't have two customer keys in the same table. They have to be unique. So we put underscore and then what they mean at the end. So that's how we keep track of our foreign keys and make them not ambiguous. We put an underscore default after a default value. In other words, it's not the only value, it's just the default, like a tax rate. You don't want people to be confused that for an order, it's just it's the only one that could possibly be. You want people to understand that it's only the default, but it might be changed manually after that or overridden. So we do that. Then we have three where we use shouting. We do them all capitals, and that's for a reason. Any suffix that we do that's all capitalized like this means that no human should be able to change this value. A calc is just a denormalized calculated value. Like if I want to quickly add up the total lines in an order and store that value, we calculate it. Maybe we calculate that with a trigger or something. Denorm is similar. We're going to store something in a denormalized location, but we'll put denorm and we'll shout it in all capital letters so that no developer will ever dare put that on a screen and allow someone to change it because it has to be calculated by the system. And then trace is a weird one. Sometimes you want to keep track of why you created a record or where a record came from. And so, or what values were used in a calculation. And so all we do is put those trace fields in for diagnostic purposes, but they're not really to be shown to the user. We're just saving them for later in case we have to figure out what went wrong. Any questions on field suffix naming? No?
No.
Okay. Now, I will recommend that you build the diagram. Remember earlier I said that I think it has value. What we do is we start off with a whiteboard or a piece of paper. That is the best database design surface you can have. We do not start designing databases generally in the SQL Server or in Access. We start with pen and paper and whiteboard. So here's a database design where we had a customer come into our office and we worked on it, and you can see it's got notes and erased lines and examples. And then I watched this. This is magic. It just transforms into an ERD. Isn't that cool? That's my PowerPoint skills. So So what we do is we lay it all out in SQL Server and try to not cross too many lines. And so I have some tips about that. But the bottom line is you start with paper and ink, you figure out what you're going to do, and then you move forward. A couple of tips. Try to arrange the tables so they don't cross the lines too much. See if you can move them around so it's attractive looking. The main tables they'll quickly show up with, you'll have your main tables and then the lines will spread out from around them. If you have a table that's everywhere, for example, let's say you have in every single table, you refer to the employee that created the record. Don't put the employee table on there again and draw lines to all those other tables. It'll just mess the whole thing up. People will see if there's an employee key in a table, they'll get that, okay, there's a reference to the employee table. You don't have to put it on every single table. We always say size the table so that all the fields are visible. I see databases all the time where the tables are really small, and when you open it up, there's like 20 fields in there. I like to see them full size so I can see the importance of the table and I can reference it when I'm building a query or something like that, and I don't have to expand the tables. So take the time to make your diagram look nice and keep those tables full size so that you can see all the fields. Now, if you're using SQL Server, you can do a couple. How many people use SQL Server? Quick, raise your hands. Almost everybody. So in SQL Server, you can put headings and section comments. So see where I've highlighted down here? That's not a table, that's just a text. How many people put text on their SQL diagrams? Oh, more people should do it. Come on. So project configuration, you can put, what I like to do is make it kind of a neighborhood. You can make a little group of tables and put a heading there, and that helps describe the diagram. And it's so easy. In the SQL diagrammer, you can just say add a text box, and you can go and type it in there, and it's great. The other thing that's nice, if you have a really big database, is make different diagrams for different neighborhoods. Like you can make a diagram that's all about orders and just orders, and you can make another diagram that's only about accounting. And you don't have to have it all in one big one, although I do recommend that you do have one diagram that has everything. But in SQL Server, you can have and name different diagrams. Most people only build one, but you can build more. Now, Access doesn't have that, unfortunately. Access only has one diagram. McCall, you could always add more diagrams to Access. And then here's what I say, deliver it. It's something that you worked hard on, and it's a beautiful, I think it's a beautiful thing when it's done correctly. So we always print it out or make a large PDF, a large scale PDF of it, and we deliver it to our customer. And you might think, well, Armen, they're not going to understand what it means. And I'm like, I don't care. It's part of what they paid for. And you might not understand what a blueprint of a building means, but you like to see it because you paid for your architect to build it. So you might as well have it. And you can always use it later to help build queries and understand where the data is coming from. So somebody at your customer will appreciate it. Okay, here's a quick trick in Access, and then I'm gonna wrap up really fast because I'm almost out of time here. If you need to make two relationships to the same table, what I always do is see how person has a relationship two ways. This is a table, internal table that tracks whether people have met each other at meetings. Well, there's a person key _1, a person key _2, because I'm just keeping track of all the combinations of people that have met each other before. Well, they both have a foreign key back to person. Normally, this person table would be on the diagram twice and it would be cluttered. But you see how I laid it right over top of the other one? This is right over top. So underneath person 1, there's TBL person, but you can't see it. But see, I was really tricky. I lined it up exactly so that the relationships are lined up. So it looks like there's two different relationships. So there's my timer to wrap it up. So you can see that person 1 is here, but I'm doing this little trick where it's only one table and I can see both relationships. I just think it's a nice, clean way to do it. And the clue to me that there's another one underneath it is that the _1, because Access puts that on there for you automatically. So you know there's another one hiding behind there. Okay, 2 more. Daniel, I know I'm going a couple minutes over, but 2 more quick cases. By the way, I am going to give you these slides. I'll give them to Daniel and he can distribute them to any way you want. So don't try to write down all these details. You can look at these later, but I'll do 2 quick examples of design techniques. First of all, remember I talked about T-val tables, which are safe to hard code against. But sometimes you need to be able to, you need a T-val that's hard codable. In other words, you need to be able to code something against it. And one of the ways is with contact methods. So there's a quick example that you can use in your applications that really is handy. Let's say I have a bunch of contacts and I don't want to put phone numbers and emails and Twitter handles and all that in separate fields. I just want to have a list of all their contact methods. So here's a one-to-many, and you can see there's phone numbers and emails in here, and there could be other things too. Then I have a lookup table of contact method types. So I have work phone, work email, personal email, etc. I could have lots in there. And the users can add those if they want. But let's say I want to send out an email blast to everyone that has any kind of an email address and automatically send it out. Well, I can't code against this lookup table because how do I know whether it's an email or not? And don't anyone dare say that I could look for the word email inside the name, because a human wrote that, and humans are terrible. So they're very inconsistent. They might spell it somehow differently, and we can never code against something that a human typed in. So what we do in our shop is we have it look up again. See here, there's another lookup to a T-val table, and it just has the word email, and let's say that's record number 1. So now I can send out an email blast to every contact method that has a contact method type that has a super type of number 1. You see how I can hard code against that now? Now some people put check marks in saying, oh, this contact method type is an email, or it is a phone number, or it's Twitter. But I don't think that's flexible enough, because I might invent a new type of super type later and want to add it to my T-val and start coding against it. And I don't want to have to add yet another flag to this table. So that's why we use super types as a way to hard code that technique. I know I went through that really fast. You can look at this later. Does anyone have a quick question on that?
No.
Okay, this is the last one, and you guys can look at this later as well, but this is how we keep track of permissions. How many people have put different permission levels in their applications? Yeah? And a lot of times it's, oh, you're a regular user or you're an admin, right? Or you're a regular user or you're read-only, and we always give the boss read-only because we don't want him to screw it up, right? So that's sort of hierarchical, like very simple permission levels. What we do is this. We say, let's create all the capabilities. We call them capabilities because they might be more than just permissions. Let's create capabilities in a T-val over here on the right, and we can code against those. In other words, if you have the capability to create a sales order, then that could be create sales order would be that capability. Now we build roles. So the role is like kind of like what your title is at the organization. Maybe you're a sales manager. So we have a role called sales manager, and the users can add as many of these as they want. Then what they do is they collect up the capabilities they want that role to have, and they put them in this group of a cross-reference of roles and capabilities. Everyone with me? So a sales manager could have 5 capabilities, but a person working on the factory might only have 2 capabilities, and you can choose which ones those are. But then you can take an employee and you can assign them however many roles they want, they need. So for example, you could say an employee is a sales manager, but is also a sales reporting specialist. And you could give them 2 different roles, and those roles come along with a group of capabilities. So now you have this very flexible system where, oh, I should say here, capabilities are always add capabilities. They don't prevent anything. Does that make sense? If you can do something, you can do it, but there's nothing where it says you cannot do something. So that's the way we can always just check to see if someone has permission to do something. The administrator has complete control. They can structure permissions any way they like. They can build new roles. They can collect up capabilities and assign them out. And they don't have to call us to do that. They can do that in their application very easily. And then all you have to do is create a simple code. In code, you create a function that you send in a user, like Daniel, and you send in, can create a sales order. And then the function returns back a very simple answer. It's either a yes or a no. Daniel is allowed to create a sales order, or Daniel is not allowed to create a sales order because that permission was not found. That capability was not found in his list. Any questions on this technique?
Is it not possible to read out the right structures from the SQL database?
Oh, like using permissions?
Yes. That you work it through in the menu system. So that
Yeah, you could. It's possible if you're talking about SQL Server like permissions at the SQL Server level. I think you are, yeah? Or no?
Yeah.
Well, we find that trying to manage the SQL Server permissions often takes somebody in IT, and we just want the application to be able to take care of it. So most of the time, our applications have a permission level at the database level of everyone is the same, and then we use this structure to guide what people can see and what people can do within that. Because otherwise, we would be changing users and permissions at the database level, which is more difficult. So this is a way that you can do it without having to do that.
And are you, do you know of any cases that ADM files were built for Active Directory? So we had ADM files that you could set extended attributes in Active Directory users and
right.
organizational units.
What we do with Active Directory is we identify the user using Active Directory. So in other words, if if Stanley needs to come in and use the database, we might identify him, or McCall, we can say, oh, McCall is logged in. We can make sure that we know who it is. So we use identity that way. But then specifically what they're allowed to do inside the application, we use this structure. So we split apart the who it is with what they can do. That's two different things for us. That's our technique. I mean, there might be other ways of doing it, but this is the way that we've chosen to do it. It's very flexible. Okay, guys, I've run out of time, and Daniel's probably starting to get restless. So
Only a little bit. You're doing well.
Oh, thanks. So I'm going to leave it here. I have my contact information, and I will give you my slides. I'll give Daniel my slides, and Daniel, you can distribute them how you need to. But I welcome any comments about my presentation or questions, and you're welcome to email me or give me a call or whatever, and we can chat more. I really appreciated speaking to your group. Thank you very much, everybody.